Okay. Hello. No. All right, we got to run the bench. So I'm going to take the glass off, so that way you don't have to look at my reflection the whole time. The only bad thing with tempered glass, it's very reflective. Okay. So basically we're going to do this the easy way. We're going to go through and we're going to strip this machine down first, and then we're going to let's see. Oh, that's right. I need to take that out. So it's got this little slot cover on here. But we have to take this out because otherwise we don't have enough room to be able to clear the front panel on the Taichi here. So, alright, take screws out here real quick. Yeah, when this card first came out, it was about $480. I did not pay that. I waited. I think I paid right around $4 for this one. Because there it is. Everybody kept saying it's a very good card for a 5700X. However, it is not worth the price. So, but you can see it's huge. It's a big old monster card, but it's got a lot of through ventilation on here. Plus, it's got 1, 2, 3, 4 heat pipes running through the 2 sets of coolers on here. You've actually got a rear cooler and a front cooler. So the front cooler basically cools the GPU, and the back of the cooler takes the load off of that one and runs. Also has a memory heatsink on it on the back cooler. So this card does run hot. The 5700 XTs all run pretty hot. So. But you get the pretty metal backplate on the back too. So it has a very, the Taichis all have very much a steampunk feel to them. So, which is cool. Alright, set these aside. Okay, so we're going to go ahead and leave our Evo Plus in here right now. If that looks familiar, it's also the same model that we used in the Epic server build. So we're going to go ahead and leave that in there for now, because we're just going to go ahead and get the board out of here first. Let's see, let's go ahead and get our cooler taken off here first. So ideally in this position we would have taken and we would have actually rotated our radiator here 180 degrees and had the tubes on the bottom. Unfortunately with this case, because we're dealing with this power supply shroud that is riveted in, yes, that's riveted in, it's too narrow to be able to get the tubes right here through, because you can tell these tubes are really thick. I actually got it in there, but the tubes had to be bent down at such an angle that it would have eventually broke the tubes over time. So it was like, yeah, we're not doing that. So we went ahead and went with this orientation because you can see with our P14 Arctic fans up here on top, this radiator is about 1.5 inches thick, And we do not have an 1.5 inch of spacing between our heatsink here and our fan. So yeah, it just doesn't quite work. I mean, it overlaps about almost 1/2 inch. And we can't get the radiator over far enough to be able to clear this guy. And with the new Creator board, the Creator heatsink is about almost 1/2 inch taller than this heatsink on this Fatality board. So yeah, no bueno. So it's gonna stay here, but that'll keep this video shorter. So eventually I'll do some more research and we'll see if we can find a case that is actually going to allow us to be able to mount this guy up on top and then take our 120 fans and actually bring them down here. So down in the front. So yeah. But yeah, the Gemini just sucks. So if anyone from Cougar is listening to this, sorry. It's a very pretty case, but as far as cooling goes, it's a disaster. So yeah, I do not recommend anyone use that case if you're going to do air cooled. If you're going to do liquid cool, if you were going to do full liquid cooling on it, it wouldn't be bad, but you couldn't do Arctic, or you couldn't do like a closed loop with a thick boy cooler, because you just don't have enough space. You don't have enough room between the top up here and the heat sinks on the power supply. So yeah, it just won't work. So all right, so there's that, and then this guy, just give him a quick twist and pops right off. And the cool thing about the Arctic is it's a one plug installation. So we have one PWM connector connects to our CPU fan 1, and that runs our 3 front fans, and it runs our pump, and it runs our VRM fan. So very simple installation as far as this part of it goes. So okay, we're going to pause for a second. I'm going to clean the thermal paste off here real quick, and we'll be right back. Okay, so went ahead and got that cleaned off, and we're just going to lay this back over here at the top of the case here, and it'll be just fine. Alright, so I'm going to go ahead and disconnect our USB 3 here. Gotta love USB 3. It always is. Tags in there kind of tight. This board actually has 2 USB 3 headers on it, which is kind of cool if you got a case that has dual USB 3 front panel headers on it. Only thing I really use that for is my external hard drive dock for doing data recovery on customer machines. So we'll go ahead and disconnect our SATA connectors. We actually have 3 connected in here. So the first iteration of this system had all SATA. It didn't have any M.2s in it. So it was one Samsung Evo SATA drive and our 3 terabyte backup drive that is actually in here in a drive gauge, with a Ryzen 5 30, no, not 30, 2400G. So, and it was a really good step up from the AMD FX 8350 that I had been running. So okay, there's that. And disconnect our rear fan there. And there. And okay, that's it. All right, so go ahead and we'll take our screws out here. So this machine, well, this board is actually about 2 years old. Originally it was a Ryzen 5 2400G with a SATA Samsung 970 EVO 500 gig drive and the 3 terabyte Seagate Barracuda backup drive that we run in this. And then it also had, so we ran Trident 3200, I believe CL16 RAM on this originally, and 2 16 gig sticks. Ended up selling that memory on another machine because I ended up putting 3600 in this after I upgraded to the 3700X, thinking I'd get a little better operation out of it, which it did, because the with the 3400G, on that memory we had to downclock it to 3066 because it wouldn't run 3200, and that was before I knew more about memory tuning and everything. I probably could have got it to run at 3200. It just would take a lot more fiddling to be able to get it done. So yeah, later on when we did the upgrade to the 3700X and the first 5700 XT card that was in here, I upgraded the memory to 3600, which has actually been a really good upgrade. So haven't complained about it at all. Especially when I started doing memory tuning on it. Very surprising that we were able to get it down to CL16, and it's been really stable at CL16, even though it's CL18 RAM. Yeah, getting the deep tuning on it actually did really well. So, and later on, we'll once we get this all tuned up and everything with the new board in it, we'll show the benchmarks. We did benchmarks of this machine with a full OC on it, this machine with just a straight default tune, and straight default, almost like an out of the box, and then we'll do the same thing with the new machine. So okay, one thing I'm going to do real quick is I'm going to go ahead and take the M.2 heatsink off real quick, which is hiding our 980 Pro, and voila, there it is. So if you watch the Epic build series, you notice I said only SSD I really trust is Samsung. Well, as you can tell, if I run it in my personal rig, running in all my other stuff, yeah, you want Samsung. Can't go wrong with Samsung. So, alright, well that's it for that, and we got one more connector down here. Oh, and the ARGB, which is right here, which, if you saw the Threadripper Arctic Freezer install, that was the port we were needing to be able to hook up the RGB on the Arctic Freezer TR50 cooler. So, oh, yep, I'm missing a screw. It's not lifting up. It doesn't want to let go. It doesn't want to leave its home. Sorry. But your time is up. And all right, that's it. Alright, here comes the new and improved Prom Queen. So if you're wondering, price difference between this board and the board I just took out, about double. This is about double the board in a lot of ways than the other, than that Fatality. Fatality is a really good board. The Fatality line was replaced with the Phantom Gaming line. For the most part in the AsRock motherboards. So, yeah. Okay. Alright, so there's that. Yeah, that's our mount plate from the old board. The fun part of this will be putting the cooler back in. Remounting the cooler, because yeah, I'm just looking to see. Oh, it's there. It's just a different color. So we do have the addressable ARGB header. It's just a different color on this one. So, which is good. We'll need it to light up our rear fan. So, alright, make sure we got the same hole layout, which I think we do. Yes. Okay, so we just gotta wiggle all this around here. And you're probably going, oh, but you haven't taken, oops, I haven't taken that out yet. That's not gonna work. Definitely gotta change the backplane. One thing with this backplane, it's actually got a ground pad on the back of it for better grounding against the back, and you can see the Thunderbolts for the Thunderbolt 3. So we got to bend that up just a little bit, and then this should just snap right in. Until new Antec versus old Antec, if you watch the Epic server build, the back plate on this does flex, which is fairly consistent with a lot of newer cases. They don't make the metal as thick as they used to, and so you get a lot more play and a lot more flex in there. So okay, so that's going to come out anyway, so it doesn't matter. And actually, while we got access to it, we're going to go ahead and just slide this out and down. for the moment. Personal rig, I didn't tie any of the cabling or anything down. I kind of do that for a reason, because I do a lot of like upgrades here and there on my machines a lot, and so I don't necessarily want everything tied down to where when I go to do something with it, I have to take the other side off and cut all my cable management tie downs all up and everything, and then get them all moved around. I just want to be able to get in and drop whatever I'm doing into here and be done. So, okay, ATX will pull out through the other side because we're not going to have room to get it through here right in a minute. Okay. So, so if you're wondering why I'm grabbing it, I'm actually grabbing it. There's a slot right here in the heatsink that's just about the right size for me to get my finger in. And so I'm grabbing it through there. I've got to roll these front panel connectors up and around this board so I can get everything in for later. Okay, so there's that. Alright, so there we go. That. Okay, cool. Everything's out of the way. Okay, sure. Lines up over here. Okay. So, because that front panel is padded, we really got to put some pressure on here to be able to get it to smush down so we can get the holes to line up. So, okay. Alright, get the first one in there and that'll help hold everything else in place. Our fan cable's stuck under the board. Oh, it's stuck around the standoff. Oh, you bugger. You can see how when I took that screw out, it really pushes the board out, and that's because of the front back panel, or the back plate, with all that padding on it. So, all that ground padding. So, we'll go ahead and stick that in there right now. There we go. Okay. There's one. So down here we have our clear CMOS button down here in the corner as well. Comes in really handy when you're doing memory tuning or memory overclocking, because you'll get your tunings down so far, and then they won't. You'll go one more setting, and sometimes they just won't. The board won't recover. It'll get stuck, and so you'll have to clear the CMOS and try again. I'm actually hoping we get a little better overclock on the CPU with this, between the better power supply and the way better VRM that's on this board. Let's see how much better performance we get just with basically overall better power delivery with everything. So I'm just going to go through here, make sure all these are seated down. Who's that guy? I'm gonna have to look and see what that is. It's a port I have never seen before. I'll have to consult that 150-page manual. That's in like 10 languages. Let's see what it says that is. Always something new. All right, there's that. So after consulting the Magic Book, that is a USB-C front panel header. So the one other difference between this board and the Fatality board is the Fatality we had two USB 3 headers. This one we have a USB 3 and a USB 3C. So fancy. Okay, all right, so now, how do I want to do this? I need to get that mounted first before I do too much. But there is also another USB 3C or USB 3 header down here as well. So we might end up rerouting this cable. I'll have to think about that. Okay, so this guy, we're going to go ahead and plug these in. So this is our front panel HD audio head cable. And then go ahead and we'll plug in our ARGB cable here. Now, ARGB is just, or RGB in general, it's kind of a pain because one, it's not keyed. Two, the connectors on them are very funky, to say the least, because they don't like to let's see here. That is chassis, fan, 2 and or water pump. So that works just fine. Get that under there so that sits nice and tight, so it's not flopping around. Okay. And oh, come on, shoot. Got our power button and everything pinched between the board and the CPU shard. The joys of black PCBs inside of a black case. Life was easier when everything was green. It was also ugly. So, You always got to work harder for anything that's pretty. Okay, so there's that. Alright, of course we're not going to hook any of this up right just yet because we'll go ahead and hook up our front panel connector. So power switch and power LED right here. This case doesn't have a hard drive LED on it, so also it does not have a reset switch. However, it does have a RGB mini controller that sits about right here on the back side. We can actually take the cable off of that and use it for a reset, and I think I'm probably going to go ahead and do that on this build. So, all right, CPU fan 1, CPU fan 2. So we're going 2 right there. 1's going to be on top. I'm just going to move. Actually, I'm not going to plug that in just yet. It's going to be hard enough trying to find it once I get this back in there. So, all right, so there's that. There we go. Because that connector runs our 2 Arctic fans. So, the one cool thing with Arctic fans is they have the connectors on them to be able to daisy chain the fans together, because you only have so many fan headers on a motherboard. So without having to buy third-party fan couplers or Y cables or whatever, makes it kind of nice when the Arctic already comes pre-wired for that. So very awesome. Okay, that's the board really. Okay, so let's go ahead and get the chip in here. So I'm going to clean it off, take it out of the other board, and I'll be right back. Alright, now of course the sockets are in the same orientation, so if you pick it up, don't set the chip back down, you can just drop it right in the other board, and voila, there we go. Okay, so now we got to take this guy off. This is the fun part about mounting the AIO pump and water block combo on this guy, is we've got to take the clip-on style connector off, which will drop our back plate down. There we go. And you can see there's no studs there now. Yeah, so we used, as Steve at Gamers Nexus called, we have to use the three-handed technique. Or we use tape. Alternative to that is actually we can take a SSD in a box and actually slide it behind the board on behind the access panel, and it will actually hold everything in place so we can actually get the cooler in there. So, because that is actually just about the right thickness. So, all right, gonna go ahead. And take the other side panel two screws out. And then we'll just be able to slide the whole machine forward, because we're on our Gamers Nexus mat, and it will, just like that, that'll hold on to our side panel, and then we can just lift this up, and you can see my hand back behind here. So let's grab the back plate, And we're going to grab one of these. Get that under there, like so. Alright, now, I need a screwdriver here. So I can hold it all up and in place. Nope. Guess that's not going to work. Like I said, third hand techniques. Well, in this case, we need a third hand that's incredibly thin. Alright, so we're going to cheat. Maybe. Maybe not. So yeah, no such thing as an easy way to do this, unfortunately. Actually, wait. No, there is an easy way to do this. Well, it's an easier way to do this. There we go. Now, look at that. Oh, maybe not. I'm gonna need to have an Arctic fan sitting over there. I should use that. There we go. That works. Okay. Yeah, so you're going to have something to hold that mounting bracket up. So that way you can get the screws through. Because the screws are just not long enough on this guy. Because these are just screws and they're just not long enough. They're standoff screws. But you've only got maybe 1/4 inch of thread to be able to grab that bracket, and if that bracket decides it wants to slip on you and fall through, you're just never going to grab it. So, alright, so take our Magic MX4 here from Antec. Get the cap off. Jeez Louise. Jeez Louise, why'd you put it on there so tight? Oh wait, I am Louise. Alright, timeout. I'm good. Oh, wait. There we go. I didn't think I put it on there that tight. I probably didn't. It probably just dried a little bit, so. Alright, so we're just going to put a nice, because the IHS on a Ryzen chip's square, I always just put a big blob in the middle. And stick that back on there. It's not so tight this time. Okay, and then we're going to put this down. Oh, squeezy, squeezy, squeezy. And check it for contact. Yeah, that's pretty good. Alright, so that'll we'll squeeze the rest of that and then we'll be just fine. So, alright. The Arctic Compound 1 works really well, but it's also fairly on the thin side compared to some of the others. So it compresses really well. There we go. There's one. So the trick with this cooler is to just get it started. Okay, so now I'll run our Z pattern here. I'll go most of the way down. Most of the way down again. And this is pretty much pre-measured, so that way when you run the screws all the way down to there, and then just get them kind of a seating torque just to make sure they're snug. You don't want to overcrank these because it's fairly thin aluminum, or thin steel, or aluminum. And so there we go. That's that. Alright, so we can take our spacers back out here. And go back over here. Alright, good deal. Okay, so now that we got that locked down and good to go, we'll go ahead and we'll start pulling out our power supply cables. So there's one. And this power supply might just be partially modular and not fully modular, so which is fine. Fully modular only really comes in handy if you're running dual power supplies, because you only need one MTX, or not MTX, ATX power connector for your machine. So you can see our hard drive here with our in our drive cage right there. That's our SATA cables, which are left over from previous iterations of this machine. And those can all come out. That's our USB 3. That's gonna stay. I think it's gonna stay where it's at, actually. So this is our cable for our. Move this up here so you can actually see. This is our RGB controller, and then that is the RGB switch. This will also double as a reset switch if we reroute it. So we'll actually reroute it under here where our front panel connector is. So you actually look at this, this is the cable that goes to the power button and the power LED and everything. So that's the cable here. If you notice right here, they actually took a reset switch and they just put a different labeled connector plug on it and called it an RGB switch. cost-effective design right there. So that's our PCIe. There's that, and okay, there we go. Let's see if I remember right. I'm gonna actually have to take the cage, and we're gonna have to slide him forward so we can get that out of there. The cage is actually going to come out, so we're not going to have a backup drive in this anymore. It's this machine is going to totally back up to the other system. The one reason for that is, you notice with the cabling, it really bumps up into the cage and makes it really inaccessible. Also, too, if we take this out, we'll have more room to be able to store stuff the extra cabling and make cable management a lot easier. Plus, the bottom of our radiator is right here, so we're going to be able to let that breathe a little bit better without that drive in here. So, okay. So, go ahead and take our power supply out. Alright, out comes you. And let's see if we can get this. No. I'll have to take these out. Okay. This is the fun part. Okay. There's our ATX. So we can get our 8-pin connectors out of here. Oh, that's right, I remember now. So, that's right, that doesn't have enough clearance, so this actually has to rotate out. But to be able to rotate it out, we have to take the drive cage out. So, that's fairly easy for this one, because as long as we get that giant snake out of the way. Alright, so there's our backup drive. This is all the extra RGB cabling nightmare that comes stock for this guy. Leave that over there for now. Let's see. That one. And this one. That goes there. For the moment. And then we can rotate this and slide this guy out. There we go. Nice little rubber boot. And this is an 80 plus gold, 650 continuous power. But if you read the fine print, it is 648 watts on the 12 volt. So, but that's max output. Realistic output is probably somewhere around 550 on the 12 volt rails. So, yeah. And then that is motherboard, 12 volt for your drives, 12 volt V2 for video card, and 12 volt V1 for your CPU for your EPS. So that's it. All right. Well, that's going to get retired. So. Okay. Well, we're going to clean this out and pause for a second, and then we'll be right back with, we'll go ahead and put the other power supply back in here. All right, got a little bit of the dust knocked out of there. So we're going to take our Thermaltake 1200 here, and we're going to stick it in here. All right, so it's going to go in this way. Fortunately, it's not any bigger physically than the Antec power supplies that was in here. Actually, it's a little thinner, so that's all right. That'll make life a little easier with it being thinner like that. So, see, if we take this cage out, then we got lots of room down here to be able to plug stuff in. So we're not going to be fighting that cage anymore. So, yeah, cages are great, but they make for a headache when you got to plug stuff in. All right, so Toughpower Grand RGB. So is it Toughpower in the power supplies grand, or is it the RGB's grand? And I think I better do it upside down, actually. I did. Alright. You can't reverse mount this power supply because it does not have hole spacing for it. So on this, on the back of this power supply, it actually has a button on here that says RGB lighting. So the fan actually has an RGB ring that actually goes around it that you can turn on or off. It's a little pointless in most cases, just because of the fact that your fan is going to face the floor. So, and with a filter on it or anything like that, honestly, you're probably not going to have enough visible light showing through to really make a difference. So, but in a lot of things in IT anymore, or the computer part industry, if we put RGB on it, it's cooler and it'll run faster. They can also charge more for it. So, yeah, big one. But all right. But like I said in the Epic server build video, because of the current market conditions for power supplies, there's not a lot of power supply availability, especially in the higher end. So you're kind of limited to what you can get depending on what you're looking for. So this one was the right price with the right output at the right efficiency. So for what I wanted to do. So it was the winner. It might be the chicken and the dinner too, but hey, that's all right. All right, so take these old cables and I'm gonna throw them over here. Oh, look at this. They put our cables in a nice little handy bag. The Antec high currents do the same thing. So, oh, they put everything in its own little bag. we're just going to waste a bunch of plastic. The one nice thing about that is we'll have a bag to be able to put the extra cables back into, so we can keep the cables separate in case we need cables later on for different builds. Okay, so we need, that's our 8-pin CPU. We're going to need that. That's our 24-pin motherboard. We're going to need that. Let's see. That's hard drive. Not going to need that. Let's see. That is a PCIe. We're going to need 2 of those. Because we can on this one, we're actually going to split the power header. So our Taichi card takes 2 8-pin power connections. So we're actually going to run 2 separate cables to it. And I think that's it. That's all we need. Oh, we need 4-pin. We need 4-pin CPU. So Molex, 8-pin. I think that other one was a standard 8-pin, or an 8-pin with a split. Hook it up now so we don't have to hook it up later. And because if we put a 5950 in this later on and we overclock it, it will pull over 200 watts. So that one does have the split in it. That one doesn't, but this one does. This one has the 4x4 or the 4+4 split in it. Oh, and it's one of those. It's got that goofy little connector on it to keep it from separating. There we go. Pop that apart like that. There we go. And that splits our 4+4. Okay. So there we go. So 2 PCIEs, our motherboard, and our CPU. Okay, so yeah, CPU goes in the top corner, motherboard goes there. Okay. All right, so okay, so that's our 24-pin. All right, so let's start with that guy. Start with the big one. Alright, so that's our 24-pin end. That's the end that goes into our power supply. So it actually goes into the far bottom side down here. So there's click, that's one. To get this all in here, I would have had to take the drive cage out anyways, so. There it goes. Molex has got to go in there just right sometimes, or otherwise it doesn't want to play nice. Okay, so now down or up? Okay, so get this kind of rolled in the shape before I stick it in there because it'll be easier to plug in. Okay, because it's got to go in and down because the connector actually sits about right here, so we got to come through this upper one over here. One nice thing about this case is the cutouts are actually wide enough. You can get the full 24-pin connector in here without having to fight anything too much. Which is a definite bonus. Oh. I'm actually bending this the wrong way, so it's got to go like this, because the clip is always on the outside, so it's going to go like that. So we go in, and there we go. And then we're going to roll it. Get our flat black licorice taffy moved around here. All right, so there's that. Drop this down here for the moment. Okay, so move that out of the way for a moment. Okay. Like that. The nice thing with this board, it's full-size ATX width, so we've actually got support out here on the outer edge, so when we plug this in, the board doesn't flex like it will on like a micro ATX. A lot of micro ATX boards will come to this last screw right here, and then it'll split. It'll end about right here where the second memory slot is. So you have this edge over here that kind of will flex as you put this in. You'll have to lift it up because you don't want to over flex the board too much. There. Alright, so there's that. Good deal. Go ahead and plug our USB 3 in while we're here. Click and down. Okay. Let's see. Oh, alright, so we'll plug this guy in while we're at it. And we'll route him underneath here and down like that. That'll keep our cable out of the way. Move this guy into our number 2. Okay. Alright, there's that. Okay, that's our case fan 1, which will actually be our CPU fan 2, but we'll run custom fan profiles, and so that way we can change these, so that way our rear fans actually blow at the same rate as our front fans without any issue. If this shroud didn't come so far, I would actually go ahead and I would put a third fan down here on our radiator so we can get full push-pull configuration, but unfortunately, you can see the shroud right here is not much wider than my finger, and we just can't get another fan down in here, unfortunately. So, not without cutting it, and I'm not gonna go to that much work for it. So, alright, so there's that. Okay, alright, so now we need our 2 CPU power cables. Okay, so we're going to have so we're going to use this one for 1, and it's got a route all the way up here, all the way up at the top here. So I think what we'll do is we'll actually end up using our drive sleds for cable management. Yeah. Okay. Okay, so there's one, and there's our other light pin. And that one goes there. All right, I'll flip it over so we can then plug it in. Okay, so get this wrapped back around like the way it was. All right, so there's that. So, okay, so this is going to roll over like this. There's one. And should be this one. Go. You always know if you got it in right because it goes in. The other half will not go in the 4-pin by itself. Alright. So then we're going to take and we're going to poke our 4-pin back out through right here like so, and we'll end up zip tying it up. Right now I'm just taking and I'm just rolling these cables flat bending them back over through this top slot, so that way we can we'll take these cables and we'll roll them down flat like that so we can get the side panel back on. And it'll keep this guy from bouncing back up inside the machine. So, and we'll do that later. Okay, there's that. Alright. Now we just need our computer power here, or GPU power. And I'm going to try to make sense out of this so that way when I plug, if I do that second GPU, it'll actually make sense when I do it. That's a somewhat of a strong if. I don't know if we'll actually have a need for it. I'm not going to do it just for the heck of it, necessarily. It might be fun to play with just for benchmarks, but that's kind of an expensive toy just for benchmarking. Because I don't foresee the 5700 Taichis dropping that much until like the new 67s come out. Then I could see them dropping in price, and then it might be worth it just for fun, but we'll see. Okay, so right here. So okay, so we're gonna drop these two down this slot here, and we'll actually end up tying them back like that, so that way try to keep our cable management nice and neat. Alright, stick it in there like that for now. Well, like I said, we'll have to go through and we'll have to cable manage this and make it all nice and neat later. So, for now, I just want it out of the way. Okay, so that should be it for power. So, good deal. So I'm not even going to put the back panel on this just yet. Or the other side panel, that is. So, because I got this guy sticking up and everything, and it's all going to be moved around. So, okay. All right. Okay, so, let's do this first. We'll go ahead and load up our memory. So, quick pause while I unbox it. Okay, so here's our 4 sticks of memory. So go ahead and stick this in. The heat sinks on the Trident is a little sharp, so especially when you're putting 4 sticks in, because it doesn't give you a lot of wiggle room. Okay. Now, if you're curious about RAM overclocking, Buildzoid is really good at actual hardware overclocking. Is his YouTube channel. If you want more in-depth detail into RAM overclocking, I had on the previous board I actually did overclock the 2 sticks, these two, the number 2 and the number 4 stick. I actually did overclock those up to 4400. It would boot, wouldn't hold stable. Did actually were able to overclock these up to 4200. 4200 at CL18. And it was actually pretty stable at that. But there was 0 performance gain between 3600 CL16 and 4200 CL18. So in some cases, in some workloads, actually degraded. Because you're actually, with Ryzen and the Affinity Fabric, you're actually running up against the timing on the Infinity Fabric versus the timing on your memory. And if you're not running 1-to-1, you don't gain anything. So in running too high, you'll actually run into a memory bottleneck and actually lose performance. So yeah, so really realistically on Ryzen, even with the new 5000 series, you really don't gain anything going past DDR 3800 CL16. So if you can keep 3800 down to CL16, you're in pretty good shape. Otherwise, 3200 or 3200 CL14 or 3600 CL16 is about ideal. So, okay. So, okay, so we need to take the M.2 covers off here. Magnetic screwdrivers always come in handy. Or screwdrivers that you've magnetized with your own magnets come in handy. Okay. And, yep, gotta take the blue plastic off there. Otherwise, it won't do us a lot of good. The thermal pad will basically be useless along with the heatsink. So, okay. Yeah, the standoffs actually are not pre-installed. So I have to take them. You actually have to install the standoffs for this one, which is kind of interesting because they're installed on every other machine other board I've ever worked on. But I guess if they can save 10 seconds on installing a standoff, I guess it's better for them and just stick it in the box. But on an ultra high-end board like this, I don't see the point. If you're really trying to save money somewhere. So, alright, so there's that. And go ahead and put our there. Heatsink back on. Oops. Oh, I hope I get that lined up here. Thermal pad's a little sticky. Okay, so that's one. Okay. Now we can get our full 7,000 megabytes per second by, I believe it's 5,000 or 5,500 megabytes per second data transfer rate. Oh, that's one big piece. All right. Interesting. I figured that was split. It's not. It's one giant heatsink. Okay. So yeah, it's one big hunk of aluminum heatsink is what that is. Okay. Go grab our other unit. Okay. And before I forget again, make sure we grab our M.2 standoff here. Now you can see this one's set up for 40, 60, 80, and 110. And if you want to know, I'm using a 5mm nut driver to run those in. So the real difference between the two slots is this one runs direct to the CPU. This one actually runs off the chipset and then runs on the PCI 4 lanes into the CPU at that point, but it runs through the chipset. So it shares data bus PCI Express line bandwidth with if you had a second video card, it would share data bandwidth with that. Anything in this lower section down here, all your SATA runs through the chipset. Your lower USB 3 runs through there. I believe even the all the front panel connectors all run through there, run through your chipset. So yeah, there's a lot of stuff that runs through the chipset. The one nice thing with the X570 versus the B550 and the A520 chipsets is the chipset runs at, I believe it's 4 lanes of PCI Express 4. So you have far more bandwidth than you do with the other two chipsets, which run PCI Express 3 and run 4 lanes. So you have the same number of lanes, but PCI Express 4 runs twice as fast as PCI Express 3. So limited bottlenecking, even if you're running a lot of data through your chipset. But that's also why the X570 has the fan on the chipset, because the PCI Express 4 chipset does run a lot hotter. It actually, if I remember right, it's almost 3 times the amount of power draw on the chipset alone than the X470 or the B550 or A520 chipsets. So, alright, now time for a video card. There we go. Now, if you notice on this particular card, there's this metal plate that runs through here. This is an integrated stress bracket or sag bracket or whatever you want to call it. But it basically keeps the card from listing down because of the weight of the heat sinks that are on it. So, yeah, again, this is a very well built card. Only the power color, or the Red Devil, the Red Devil and the Sapphire cards actually benchmarked better than in testing than the Taichi did. The one thing about the Taichi is actually it's got 6 video outs on it, and not just 5 or 4 like most of the other cards do. So, okay, and I ran those through the wrong holes because we need to come through this guy and not this lower one down here. So, alright, fix that. Hung up on something. Oh, we're hung up on the split connectors here. You can see why J2 Cents always says, you know, if you get the nicer cables, then you don't run into this other stuff and it makes it a little prettier. Well, that's true. Maybe we'll do that at a later date. Me, I just really want to get this in here and start playing with it. So I'm not so worried about the overall aesthetics at the moment. My stuff, I don't care about the overall aesthetics. Your stuff as a customer, I actually do care about it. So, so don't think for a second that just because on my machine, my personal rig, I don't care so much that I won't care on yours. And that's not true. The difference is your machine, you're probably going to upgrade it once, maybe twice in the time frame that you own it. Where my machines get upgraded, at least once a year, if not every 6 months sometimes. Just because, one, I want to see how the new hardware runs, but two, it's in the case of like this upgrade, there's a real reason for doing it, not just it's like, ooh, I want to spend a bunch of money. Oh no, that's not the case. There's actually a real world reason why we want to do this. So use case and application are always the leading factors in why you do something. Granted, there are people out there who'd like to just upgrade just because they want the latest and greatest thing all the time. Well, you know what? That's fine. Make sure you call me when you want the latest and greatest computer, and we'll get you taken care of. But and if you want to upgrade every year, so, and that's fine. But you know, otherwise, yeah. Most cases, you're gonna buy the machine and you're gonna run it for at least 2 years as is, and then maybe upgrade it once, and then I mean, if you're really into like competitive gaming or something like that, yeah, you're gonna probably upgrade your machine once a year if you're really competitive. If you're not that competitive, then yeah, you're probably going to upgrade your machine every couple of years. Interesting statistic is they went through, I believe it was Linus Tech Tips, went through and they looked at the most popular system configurations on Steam, and the most popular system configuration on Steam is like basically 4 years old. It's nothing super fancy, especially in video cards. It was a lot of 970, 980 video cards predominantly, with a few like 1080s and 1060s thrown in there. But yeah, it wasn't a lot of, you know, 5700Xs or RTX 20 series or anything like that. So, okay. All right. Well, that's good enough for the moment. So we can at least get her turned on. So that's it. All right. So we're going to get this thing booted up, test it, make sure it runs, and then we'll get it all buttoned up nice and pretty. We'll take some pictures and we'll get some benchmarks done on it. And we'll see how much better we do overall. So check in for the final video.